Hi GeoH. Today we're doing Unit 3, Lesson 4, and we're doing something called CPCTC. So a lot of times when we're doing these triangle proofs, we're not necessarily just trying to prove the triangles are congruent. That's what we've done so far. But now we might be proving the triangles are congruent and then something else after that is congruent, like the corresponding part. So that's what the CP stands for. We might be trying to prove that something's perpendicular, or we might be trying to prove that something's bisecting an angle. All right, so CPCTC stands for corresponding parts of congruent triangles are congruent. And you're allowed to use that abbreviation on the regents or on a test. So CPCTC. It's a simple idea that if two triangles are proven congruent, then their corresponding parts, either the sides or the angles of those triangles, must also be congruent or equal in measure. So let's look at our first exercise here. And we have triangle EAC, and that's on the left, and I have triangle FDB, that's on the right. I want to state the corresponding sides and angle pairs. So AE right here is going to be congruent to DF. And I can tell by looking at the picture, but I can also tell by the letters. Remember, AE is the first and second letter, and DF is the first and second letter. So the order of the letters tells me. EC, which is right here, okay, is congruent to FB. And then that base AC is congruent to DB. So those are my corresponding sides. My corresponding angles, angle A is congruent to angle D. Angle E is congruent to angle F. And angle C is congruent to angle B. All right. So a good illustration of the type of thinking that goes into using CPCTC concerns the perpendicular bisector of a line segment. So we were talking about this back in Unit 2, perpendicular bisector, and here's a geometric fact. Any point that lies on the perpendicular bisector of a line segment will be equidistant from its endpoints. So if I have a line segment and I have another line segment that is perpendicular and it bisects it, what this is saying that any point on the perpendicular bisector, so here's a point on the perpendicular bisector, it will be equidistant from the endpoints of the line that I was bisecting. Okay, so we're going to do a little proof down here. In exercise 2, I have line M is the perpendicular bisector of AB. Point P lies on M. We want to prove that P is equidistant from A and B no matter where it is on M. So the first thing I'm going to do is I'm going to draw in AP. Get my pen. So AP, and I'm going to draw in BP, and I'm going to measure them. So now if you don't have a ruler, that's fine. I measured them for us. So AP is actually equal to BP. They're both 1.5 inches. All right. Given that M is the perpendicular bisector of AB, I want to prove that triangle APC, because I've now created triangles by drawing in AP and PB, is congruent to triangle BPC. So I'm going to start with my given, and that's M is the perpendicular bisector of AB. And I'm going to prove, that should be a 1. And I'm going to prove that my triangles are congruent to each other. So if it's the perpendicular bisector, it's a bisector, it's cutting that in half. So basically AC is congruent to BC. So let's write that down. AC congruent to BC. How do I know that? Well, because it was a bisector, so just definition of bisector is perfect. It's also perpendicular. So the fact that it's perpendicular means that it forms right angles. So I'm going to call these angles right here angle 1 and angle 2, and I'm going to say they're right angles. Remember, this takes 2 steps. First I say they're right angles, and then I say they're congruent. So angle 1 and angle 2 are right angles. Why? because of definition of perpendicular lines. And then if they're both right angles, they have to be congruent to each other because all right angles are congruent. So we've done those steps a bunch of times. All right angles congruent. Okay. Now I'm trying to prove the triangles are congruent. So far I have one side and I have one angle. And if you remember, one thing that you have to look for that won't be in the given is if they share a side. So CP is congruent to CP, and that reason is reflexive property. So anytime something's congruent to itself, I'm running out of room, but that's okay. I'm going to say triangle APC is congruent to triangle BPC because I have side angle side. All right, so I did it. I proved the triangles are congruent to each other. Now, once the triangles are congruent to each other, that means all of the rest of the corresponding sides and the rest of the corresponding angles that I haven't proven yet also have to be true. All right, they also have to be congruent. So part C says, why does it now make sense that AP is congruent or equal to BP? So AP is equal to BP. AP is right here, and BP is right there. So if you think about it, since the triangles are congruent, then all the corresponding parts are congruent, which is what I just said a minute ago. So since the triangles are congruent, the rest of those corresponding sides and angles, we call them corresponding parts. So since the triangles are congruent, then all the corresponding parts are congruent. So AP has to be equal to BP. How do I write this in a proof? It's just one more step. So I do the exact same thing that you just did, but I add on the last step 7 and I say that AP is congruent to PB, and the reason is CPCTC. Corresponding parts of congruent triangles are congruent. So you're doing your normal proof, and then once the triangles are congruent, you can say any of the rest of the corresponding sides or angles are congruent, and the reason is CPCTC. All right, so let's flip over to the second page. Anytime you're doing a geometry proof, and what you're trying to prove is that two segments are congruent, equal in length, or two angles are congruent, equal in degree measure, then you will likely use CPCTC. But very important, first need to prove the triangle's congruent. In order to use CPCTC, you have to first say that the triangles are congruent because it stands for corresponding parts of congruent triangles. So the triangles have to be congruent. So exercise 3, we know that AB is congruent to CB. And so I'm going to change up the color here, blue. AB is congruent to CB, and BD bisects ABC. So I'm bisecting ABC, bisecting ABC. ABC is being cut in half. So that would make angle 1 congruent to angle 2. We would like to prove that BD must also bisect ADC. All right, so what would we need to prove to show that BD bisects ADC? ADC is over here. If I want to prove that ADC is being bisected, then I really would have to show that angle 3 and angle 4 are congruent to each other. If angle 3 and angle 4 were congruent, then that would make BD bisector of ADC. What triangles should we show congruent in order to show that? Well, the triangle on the top, triangle ABD, and the triangle on the bottom, triangle CBD. So basically, I'm going to prove the triangles are congruent. Then I can say that angle 3 is congruent to angle 4 by CPCTC. And if that's true, then that would mean that BD is bisecting angle ADC. So you're going to prove these triangles are congruent and that BD bisects ADC. So I'm going to always start with my given. They told me that AB is congruent to CB, and they told me that BD bisects angle ABC. I've already marked that all on my picture. If I am bisecting an angle, that means I'm cutting an angle in half. I've already marked angle 1 is congruent to angle 2. So I'll write that as a step. Anything that you mark on your picture is for you, but you still need to make sure that you're writing it as a statement with a reason. So angle 1 is congruent to angle 2, because definition angle bisector, there are two kinds of bisectors. Bisectors for line segments and bisectors for angles. For angles, I'm always going to put that angle symbol in there. Now remember, I'm first trying to prove my triangles are congruent. They share that side in the middle. So I'm going to say BD is congruent to BD. Reflexive property. And then I actually have enough to say that my triangles are congruent. The reason that they're congruent is side angle side. So triangle ABD is congruent to triangle CBD. Once you have the triangles congruent, the rest of the corresponding sides and angles are congruent. So now I can say angle 3 is congruent to angle 4. And that's my new word for this lesson, CPCTC. Corresponding parts of congruent triangles are congruent. And if angle 3 and angle 4 are congruent, then that means that BD bisects angle ADC, which is what I was trying to prove. And the reason is definition angle bisector. Because the angles are congruent in step 5, then that makes it an angle bisector. Okay, so that's essentially what we're doing with this CPCTC. The last one right here, we don't have to do a formal proof, but it says in the diagram it's known that AD bisects BAC. So if I'm bisecting BAC, that makes these angles congruent to each other. And it's also known that it's perpendicular to BC. If it's perpendicular to BC, then that makes those right angles and congruent to each other. And they're asking, is that enough to conclude that ABC is isosceles? Well, in order to be isosceles, you have to have these two sides congruent. If I could prove the triangles are congruent, then I can say those two sides are congruent by CPCTC. So can I prove the triangles are congruent? Absolutely, I can. Angle 1 is congruent to angle 2 by angle bisector. And this is just an explain your thinking, it's not a formal proof. Angle 3 is congruent to angle 4 because they're both right angles and all right angles are congruent. So angle 3 and angle 4 are right angles and congruent. Okay, and they also they share this side in the middle. They share AD. AD is congruent to itself. AD is congruent to AD by reflexive property. Okay, therefore my triangles are congruent by angle side angle. And if my triangles are congruent, then AB has to be congruent to AC by CPCTC. And if those two sides are congruent, then it's an isosceles triangle. Since two sides are congruent, then ABC is isosceles. So not a formal proof. Okay, and that's